Hello grade 12s, welcome back to another video. In today's video we'll be doing organic chemistry reactions. So I have done previous videos on organic chemistry and I will link them in the description box down below. So make sure to check them out so that you can get a complete playlist. So without wasting any more of your time, let's get right into it. So the first organic chemistry reaction is combustion, which is oxidation. So it only had combustion, and oxidation only happens for hydrocarbons, which is an alkane, alkene, and alkyne. Okay, so it only open for that. So we take a hydrocarbon. Hydrocarbon can either be an alkane, alkene, or alkyne. Okay, so here we have a hydrocarbon. You mix it with two O's, oxygen atoms, and then they have to produce a carbon dioxide and water. That will be the results. Okay, so for example, here we have this formula here. So this has 6 hydrogens, which means it's 1, 2, 3, 4, 5. Sorry, I started with H. H is not, we have to have 3 carbons. Then it's like this. We have H here, H here, H here, H, 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 H here. So this one says we have 6 H's. So let's say it's like this, and then there's maybe boron. Okay, not a boron. We need to have a double bond. Okay, let's draw it like this. We have C, C, C. So yeah, we can just, let me just do this. We'll have H here, we'll have H, and then here will be a double bond, and then will be an H, this, and then we'll have H, H, H. This double bond is coming to this H. So even if we do it in a straight line, we'll have C, that will be double bond, and then we'll just have like that, because this one here will have another H, this one will have its H, and this will have it. So it's just a double bond here. So this will be the structure like that, and this will be an alkene. So we will have C3H6, then we add that with O2. Just like I've said, you always, this is combustion oxidation, you take what you're given plus O2. Yeah, you'll be given, let's say 9O2. So what you will get as a result is that you will get the C, this C, one C from here, and these 2 O's will form a CO2, which is a carbon dioxide. They always have C. So you'll take 1 C from here and these 2 O's. Always, this will give you that. And then you will also write H2O like that. So that is how you get the outcome of this will be this. Okay, so now you have to know how to balance your valency electrons. You have to, not your valency electrons, sorry, your ratios. So you have to know how to balance. This is C2, or we can throw in a 2 there, and then we have 2C, C3H6 plus 9O2. This is what they will give us. Now we have to balance this. So step 1, you have to balance metals. You don't have metals. Step 2, balance non-metals. So they are all whatever that we have here is non-metals. So we'll start with C, except carbon and hydrogen. It's not carbon, oxygen and hydrogen. So you just leave out oxygen and hydrogen. So we have C this side, on this side, on the left hand side, we have 2 times 3, that is 6. And then C this side is just 1. So that means the C's are not balanced. So for them to balance, we also need for the right hand side to be a 6. So I'm going to take out another color, and then we're going to add 6 this side. After adding that 6 that side, it means that our C's are balanced. And then after that, we are going to balance. Step 3, you have to balance hydrogen. Now hydrogen this side is 2 times the 6. So we see that hydrogen is 12 this side, and the hydrogen here is 2. So this is not balanced. So what will we add here to make this hydrogen balance? So for it to balance, we have to add 6 that side. So 6 times the 2, we can only change these front numbers, not this ones. So for us to have that, and now hydrogen is now 12, and hydrogen is balanced. And then step 4, we balance oxygen. So we look for oxygen this side. For our oxygen, we have 9 times the 2. For oxygen, we have 18 this side, and then this other side for oxygen, we have 2 times 6, which is a 12. And then we have this 6 applies for hydrogen and oxygen, so we have 12, 13, 14, 15, 16, 17, 18. So 18. So this is our balanced equation. So always remember that this is how what the combustion and oxidation looks like, always. So you will be given this, and then you have to produce this, and after that you have to balance. So the second one, we have substitution reaction. Substitution only takes place with single compounds with single bonds, which is alkane, alcohol, and haloalkane. So that is where substitution takes place. So let's say it only deals with halogen atoms, né? So it can be an alkane and a haloalkane. It can be a haloalkane and an alcohol. It can happen between those. Okay, so it can happen between an alkane to a haloalkane, and then between a haloalkane and an alcohol. So they are, that's how the substitution reaction will happen. So let's take this. This on its own is an alkane, but we add Cl, it's something completely different. So for it to be called substitution reaction is that the Cl will replace the H in the new diagram. So let's say you have it like this. You have this one, and then this Cl is at the end like that. We'll just redraw this. This is H. It means this halogen atom, all the halogen atoms replace oxygen, hydrogen, sorry. The halogen atoms replace hydrogen. So that will be like that. We have our H, and then here at the end we'll have Cl. You see? So we had our H's like this, but here at the end, we can have as Cl. Okay, or we can have it as HCl. Or let's say, for instance, we have, it's still 2 carbons. This marker is not working properly. The black ones are just a mess right now. So we have this, and then we have H, and then we have Cl2. Well, this C1 halogen atom has to replace the oxygen, the hydrogen. So we'll just have our C's like this. This is H, 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 and then this is H as well, and H as well, and that will be Cl, and then this Cl will be plus HCl. Because we had 2 Cl's, the one has taken this, has replaced the oxygen here, and the other one, we're adding it here. Or we can still add this one here, but stick to adding it here at the end. So just know that a halogen replaces oxygen at the end with substitution reaction. Now let's look at addition reaction, where an alkene form compounds with single bonds. So an alkene plus haloalkane. Single bonds, remember, we just did them, is halo, it's alkane, haloalkane, and alcohol. They have single bonds. So here we are going to go from a unsaturated to a saturated. Okay, remember, go back to us my previous video if you don't know the difference between saturated and unsaturated. So here we are having this whole thing here. Okay, so the double, what we are trying to destroy is this double bond. So where we have this double bond and a structure is not fully surrounded, like when this H's, we have everything everywhere like this. This is saturated. Now when we remove these 2 hydrogens and just do a double bond, this is unsaturated. So this has to be saturated. We are going to saturate it by these 2 Cl's that we are given here. Okay, so here is how we saturate this. So it's H here, H this side, H this side, H this side. So for these double bonds, we're just going to break them and make them single so that we can have Cl here and Cl there. So this is how we make it saturated. So that is how reaction works. We added the Cl's to a unsaturated structure to make it saturated. The fourth organic chemistry reaction is elimination reaction, where compounds with single bonds, alcohol, alkane, and haloalkane, form compounds with double bonds. Now the double bonds is the double bonds ones, as I have previously said, is that we have alkane and alkyne. Those are the double bonds. Sorry, alkynes has a triple bond, so alkenes have double bonds. Yes, so let's go to the structure. So with this one, which is called elimination, is getting rid of hydrogens. Let's say hydrogens or halogen atoms. So let's say we're having this structure. When we want to eliminate, this is saturated, maybe let's take it to unsaturated. Okay, this is what we call dehydrogenated, which means hydrogen have been removed. So when we say dehydrogenated, it means you remove hydrogens. So we have removed 2 hydrogens and made this a double bond carbon. Okay, so from alkane to alkene, this is where we are. Oh, let's see. We have 2, 2, 4. Okay, let's do them. Let's just do 4. So we will have the Cl here, and then the hydrogen, and then the hydrogen. Okay, so what we do also, let's remove the 2 hydrogens. Oh yeah, we can just remove 1 so that, okay, let's just make that last C, and then have H, H, H. So what we can do is to dehydrogenate, do hydrogenation. So we're going to, this is another structure. I'm going to have H, 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 on top, H, H. This is 1, this is 2, 4, 5. So we'll have H here, and then we'll have H here. Remember here we had H, H, and Cl. So we'll just add the H here plus HCl. So you see, from saturated to unsaturated by just dehydration. So removing hydrogen atom, and we can only remove hydrogen and halogen atoms. So I hope you guys understand what I am trying to explain. What is elimination, substitution, oxidation. Thank you very much for watching, guys. Until the next one.